watching this video. Myself Ankit.M.Biradar from Civil Department, and I am going to represent on behalf of my group. My group members are Mr. Gaurav.R.Kudale, Mr. Sushant.S.Shelar and Ms. Roshni.M.Upare. So today I am making this video. As we all know, our final year project presentation competition is going to be conducted through video recording mode. So in this video I will cover all the points which are included in our project. So I would also like to tell you that we completed this project under the guidance of our respected faculty member and our project guide Mr. J.K.Patil sir, and we also got a lot of help from our Honorable HOD of Civil Department Mrs. Smita.V.Mahamuni ma'am. So before starting the presentation, I would like to introduce to the vision and mission of Civil Department. Vision of our department is to develop self-reliant, quality-conscious and innovative civil engineers useful to the industry and society. The mission of our department is to impart quality and real-time education to contribute to the field of civil engineering, to impart soft skills, leadership qualities and professional ethics among the students for their successful career, including entrepreneurship, to create mindset among the students for their lifelong learnings and social benefits. And now, with all your permissions, I would like to start the presentation. Title of our project: Assessment of Suitability of Coconut Shell Charcoal as a Filler in Stone Matrix Asphalt. So you all might be wondering that what the coconut shell charcoal really is. The coconut, we all know that we purchase coconuts and then drink it and put it in dustbins. But we can use this waste material and convert it into useful products. I will tell you how. The coconut shell charcoal. The extraction of coconut shell charcoal process includes 3 steps. The first is cutting, second is ripping, and third one is burning. The first one, that is cutting, in which we cut down the coconuts from the trees and then we dry it for some days. We can also use the coconuts from the dustbins. The second step, that is ripping, in which we remove the outer cover of the coconut and we remove it until the coconut shell is properly visible. In the third step, that is burning, in this step we burn this coconut shell in open air for around 3 to 4 hours and then we incinerate it in a furnace for around 800 degrees Celsius at 6 hours, and then finally the product that is obtained is coconut shell charcoal. Objective. The objective of our project is to use coconut shell charcoal as a filler in stone matrix asphalt and then compare its properties with other fillers and to check whether the stone matrix, whether the coconut shell charcoal is really sustainable at heavy loads and high temperatures. And the method which we have used to determine the flow characteristics and stability values is the Marshall method. Introduction. In introduction, I would just like to tell you that aggregates are mixed with bitumen and used worldwide for construction and maintenance of flexible pavements. SMA was first carried out in Germany in the year 1960 by Zissner of Strasbourg Central Laboratory. SMA consists of 70 to 80% of aggregate, 6 to 7% of binder, 8 to 12% of filler, and about 0.3 to 0.5% of fibers or stabilizers. The factors which affect the performance of SMA mix are: first is the change in binder source and grade, then second is type of aggregates, environmental condition, and the fourth one is production and construction method. Fillers. Fillers are the fine particles which are obtained when it is sieved through 2.36 mm sieve and retained on 0.075 mm sieve. All the fillers that we have used in our project are the waste materials such as stone dust, fly ash, Portland cement, and the main one, coconut shell charcoal. The main purpose of using fillers is to reduce the voids between the coarse aggregates and the fine aggregates, which increases the compaction and stability of pavements. So these are the fillers: stone dust, Portland cement, fly ash, and the main one, coconut shell charcoal. And these are the list of materials which we have used. We have used coarse aggregate, fine aggregate, stone, all the types of fillers: stone dust, Portland cement, fly ash, and coconut shell charcoal. And for binder, we have used bitumen, that is 6 to 7% of total mass. And for the stabilizer, we have used cellulose fiber, that is 0.3 to 0.5%. So now we'll move on to experimental procedure. In sieving, first we have to clean and dry the coarse aggregates and fine aggregates, and then we have to sieve it through a range of sieves ranging from 19 mm sieve to 0.075 mm sieve, and after sieving we have to separate it according to their sizes. After sieving, the next step is mixing. In mixing, we have to mix the coarse aggregates and fine aggregates thoroughly so that the gaps or voids between them reduces for better stability and compaction. And we have to continue this sieving for 5 minutes. And after that, we have to keep this sample in heating oven for about 160 degrees Celsius at 1 hour. And after this, we have to remove this sample and mix it with bitumen as per the requirement. In molding, as you can see, my colleague Mr. Sushant.S.Shelar is doing the compaction process. So in this process, the material which is obtained after mixing is compacted in Marshall compaction molds. So in this process, what we have to do is we have to compact this material with a hammer. This is the hammer which is of weight approximately 4.5 kilos, and then we have to drop it from a height of 40 centimeter. We have to, for proper compaction, we have to give 50 blows, and after that we have to allow the sample to dry for about 24 hours. And after 24 hours, we have to remove the sample from the mold with the help of sample ejector. So after molding, these are the samples which we get, and after this we have to weigh them. We have to measure the radius, and we have to also measure their heights. And after that, we have to apply a layer of wax around them, and again we have to dip them in water and again measure it. The next step is hot water bath. In hot water bath, we have to immerse these SM mixes in hot water which has the temperature of about 60 degrees Celsius, and we have to keep it immersed for around 30 minutes. But we have to take a special care that the temperature should not rise above 60 degrees Celsius, and the duration should not be more than 30 minutes. Otherwise, if such condition occurs, the sample would be worthless, and we won't get the right results during testing. The next and final step is Marshall test. In this test, we have to use Marshall stability test apparatus, and by using this test, we can get the flow characteristics and stability values of mixes. As you can see, I have already placed our sample in this machine, and now to operate this test, we have to load this sample at a constant. We have to apply load to the sample at a constant rate of 5 mm per minute until the complete failure, and the total maximum load which we get until the complete failure. In this test, we have to apply load on our sample at a constant rate of 5 mm per minute of deformation, and the total maximum load which is obtained, that is the value which we obtained, is taken as Marshall stability value, and then it is corrected by using correlation ratio table, and the amount of deformation that is caused due to the maximum loading is taken as flow value. And after this test, finally the results we have got after this experiment, and we have concluded that the maximum stability value by using stone dust as a filler in SMA mix is 9.1 kilonewton, and the same by using coconut shell charcoal is 8.4 kilonewton. So the stability value of coconut shell charcoal is more than 8 kilonewton, so it can be used as a filler for pavements. And we have also found that flow value increases with increase in bitumen content or binder content, and the air voids reduces with the increase in binder content. And finally, we can conclude that coconut shell charcoal can be used as a filler in Stone Matrix Asphalt, as it satisfies all the criteria to be used as a filler. And finally, we have successfully completed our project, and I would like to tell you that stay at home, stay safe, and stay healthy. Thank you.